Hello everyone, this is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. In the last session, we have discussed bisection method, how to find root of a function f of x is equal to 0. In this session, we are going to discuss a regular falsi method in numerical techniques. So, this is also one of the root finding technique to find root of the function f of x is equal to 0. Then how to find root of the function f of x is equal to 0 using regular false method. So, we have already discussed in the last class the intermediate value theorem. So, we can find the root of the equation that the property that f of a into f of b less than 0. So, f of a into f of b less than 0 means there exist two cases, that is first one is case 1 is f of a greater than 0 and f of b less than 0. Next, the other case 2 is f of a less than 0, f of b greater than 0. So, I am assuming one of these cases. So, I am taking this f of a is greater than 0 and f of b is less than 0. So, this I can explain using graphically. So, this is the y axis and this is the x axis. Now, my a is, so a and b are the initial values. So, I am taking a here and b, and this is my f of a, because f of a is positive. So, I am taking f of a here and b is negative. So, f of b is less than 0. So, this is f of b. So, I am taking the coordinate point, this a comma f of a and this is b comma f of b. Okay, so I am taking the curve y is equal to f of x crosses the x axis by joining these two coordinates. So, this is the curve y is equal to f of x which crosses the x axis at this point. So, this is the root of the equation, and I am taking this coordinate as a and this as b. Okay. Now, so how to, in the bisection method, we take the midpoint to find the root of the equation. Here in this case, so we are joining the coordinates a and b. So, we are joining the coordinates a and b by a straight line. So, this is not exactly the straight line. So, I can take, so by joining these coordinates a and b, and this straight line touches the x axis at this point. So, how to find the equation of AB? So, we can find the chord joining these two points A and B. So, the equation of AB is y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. Okay, here, so x1 is a and f of a is my y1 and x2 b, f of b is y2. So, now substitute these values here. So, y minus y1, that is y minus f of a divided by x minus x1, that is a, is equal to y2 minus y1. So, here f of b minus f of a divided by b minus a, x2 minus x1 is b minus a, but this line cuts the x axis when y is equal to 0. So, the line touches the x axis when y is equal to 0. So, that means y is equal to 0, substitute here. So, we can take 0 minus f of a by x minus a is equal to f of b minus f of a divided by b minus a. Okay. So, now we can continue this minus f of a. minus f of a is equal to, so I am writing f of b minus f of a divided by b minus a into this x minus a is sending to the right side. So I can write here x minus a. Now, so f of minus f of a into b minus a is equal to f of b minus f of a into x minus a. So this f minus f of a into minus f of a into b minus a divided by f of b minus f of a is equal to x minus a. Now x is equal to, I can write this as a minus f of a into b minus a divided by f of b minus f of a. Now take the LCM of this, we get x is equal to a into f of b minus a into f of a minus b into f of a, minus into minus plus. So we take a into f of a. So this is b minus a, right. So divided by f of b minus f of a. Now here we can cancel minus a into f of a and plus a into f of a. So x is equal to a into f of b minus b into f of a by f of b minus f of a. So this is the new root. So x is equal to a into f of b minus b into f of a by f of b minus f of a. So here this is the new root x. Now if we take this next coordinate here, so this is the new coordinate, then if I join again a straight line to this point, this coordinate, okay, so then I will get another point. This is the next approximation root is x2. So let us take this x1, then we will continue this process until to get the desired accuracy root. Now we will see the example of this regular falsy method. So find a real root of the equation x cube minus 9x plus 1 is equal to 0, correct to 4 decimal places. Now let us take let f of x is equal to x cube minus 9x plus 1 is equal to 0. So now we have to take the initial guesses. Here interval is not given, so let I am taking x is equal to 1. Now which implies that f of 1 is equal to 1 cube minus 9 into 1 plus 1. So this is equal to minus 7, which is less than 0. Now take another value, x is equal to 2. So f of 2 is equal to 2 cube minus 9 into 2 plus 1. So this is equal to 8 minus 18 plus 1, so minus 9. This is also less than 0. Next take x is equal to 3. So which implies that f of 3 is equal to 3 cube minus 9 into 3 plus 1. So 27 minus 27 plus 1. So this is equal to 1. So which is a positive value greater than 0. And therefore the root lies between opposite signs, opposite values. So by based on intermediate value theorem, so therefore the root lies between 2 and 3, because f of 2 and f of 3 are opposite signs. So we take this as a and this is b. Now we will continue with this through the table. So this number of iteration number is n and a. So here a is a negative value. So let us, for our convenience, we are taking this as minus sign, and this is positive. So the functional value is positive. So our convenience we are taking as plus, and this x is equal to a into f of b minus b into f of a by f of b minus f of a. So using this result we can find the value, next approximation root, and f of x. Now so here we got the root lies between a and b, that is 2 and 3. Now we substitute these values and finding f of a and f of b. Okay, we can substitute in this x, we'll get the value is 2.9. Now the value, if we substitute this 2.9 in the given function f of x, so we'll get minus 0.711, so which is less than 0. So now we replace the negative side value, so this is replaced by this 2.9, and we write this b as same as it is. Again we'll substitute this, we'll find f of a and f of b for these values and substitute in x, we'll get this x value as 2.9416. If we substitute this 2.9416 in the function f of x, we get minus 0.0207, which is less than 0. So again we replace the negative side value, so this is replaced by this value and this will be the same. Now again we find f of a and f of b and substitute these values in the equation x, so we'll get 2.9428 and its functional value of is minus 0.0003, which is also less than 0. So again we replace this value, negative side value, because negative, so we replace this value with this one, and this same remaining, we are not changing this value, we are writing as it is. So we are finding f of a and f of b and substituting in this equation, so we'll get 2.942817. So its functional value is minus 0.0005. So we can stop the process here because we got the two up to 4 decimal places. So 2.9428 and 2.9428 are the same, two consecutive roots are same. Then we can stop the process. So the required root is 2.9428 is the required solution. So in today's session we have discussed a regular falsy method, and in the next session we are going to discuss iterative method. Thank you.